So in this exercise, we are given a force which is changing with position. The force Fx is a function of x and is equal to 28 minus 5.0 x. And x is measured in meters and the force is measured in newtons. So this force is a horizontal force, which is a function of x, and is acting on a block of mass 3.9 kilograms. So the mass of the block is 3.9 kilograms. The block is placed on a rough horizontal surface which has a coefficient of kinetic friction, mu k, 0.22. The question is, what distance should the block travel if it starts from the origin, so that the total work done on the block by force F and by the friction force combined is equal to 0. So the mathematical condition that is set is that the work done by the force F plus the work done by the friction force combined is equal to 0. Now let's first calculate the work done by the force F. Now we know that in a simplified form, the work done by a force is equal to the force dot displacement. Now this is for a constant force, and d is a displacement vector. However, if the force is not constant, then instead of using work, we can use the element of work. So we will have dW, and instead of d, we will have dx. Okay. Now, in our case, the force F is horizontal, so instead of having f dot dx vectors, we will just have f dx because they are parallel. So then we can just substitute for f, and we have 28.0 minus 5.0 x dx. So this is the element of work done by the force F. Now, in order to find the total work done, we need to integrate it over a certain distance, which we're looking for. Let's say that at the distance L, the combined work of the two forces is equal to 0. So let's integrate this from 0 to L. So Wfx would be an integral from 0 to L of dW, or integral from 0 to L of 28 minus 5x dx. So this integral is then equal to 28L minus 5, and x becomes x squared over 2, so you have L squared over 2, or 28L minus 2.5 L squared. So what do we do with the friction force? Now let's calculate the work done by the friction force. Well, the friction force will be always parallel, actual anti-parallel, to the displacement. If the object is moving to the right, then the friction force will be pointing to the left. So the two vectors will be opposite to each other, and therefore when we take a dot product, a negative sign comes out. So we have minus L times the friction force. The friction force is related to normal, so this will be mu k times the normal. In the vertical direction, there are no other forces except for normal and the gravity acting on the block, so we can say that the normal is equal to mg. So now we can take this and plug it into the overall expression. So the work done by the force F is this. So this is 28 L minus 2.5 L squared plus the work done by the force of friction, which is this. So negative L mu k mg equals 0. So let's go ahead and calculate what this prefactor here equals to. Now we are given the coefficient of kinetic friction, we're given the mass and the free fall acceleration. If you do the math, this gives you 8.42. Okay, so just calculate coefficient of kinetic friction times the mass times the gravity. So now we have 28L minus 8.42L. So this gives you 19.6L minus 2.5L squared equals 0. So we can take L out, and we have 19.6 minus 2.5L, which is 0. And as you can see, this equation has two solutions. The first one, L1 is equal to 0, which is trivial. Obviously, at the very beginning, when we haven't traveled any distance, the total work is 0. Makes sense. And the second one, L2, is 19.6 over 2.5, which is then equal to 7.84 meters. So when the block travels 7.84 meters, the total work done on the block by these two forces combined is equal to 0. That's it.